The final topic we're going to cover in this unit is going to be the law of sines. So the agenda, we're going to kind of recall what it means to solve a triangle. Then I'll teach you the law of sines, and finally I'll show you why it works. So recall that we began this topic with one goal in mind: to solve triangles, finding all the lengths as well as all of the angles. And after various lessons, we accomplished our mission. We found a lot of techniques for finding lengths and a couple of techniques to find the angles. We found success. However, we have a problem. The problem was that our techniques are geared towards right triangles. That's why this unit is called Similarity in Right Triangle Trigonometry, because all of these techniques are only valid if you have a 90-degree angle. However, as we exit this unit, I want to leave you with a question in mind. What about triangles that are not right? What about something that looks maybe like, whoa, not like that? What about a triangle like this one? There are no right triangles, but is it still possible to be able to solve for the lengths and, well, if we didn't know the angles, for the angles as well? And the answer is yes. The remedy is the law of sines. There's also another technique called the law of cosines, but I'm only going to be teaching you the law of sines. So here's what it says. The law of sines can be used to find a missing side or angle in any triangle. It does not have to be a right triangle. So here's how you use it. Let's say I get angle A. Across angle A is the length lowercase a. So I can say that the sine of the angle capital A to the length lowercase a, that's going to equal, and now we can choose another angle. I'm going to choose B for simplicity. It's going to equal the sine of capital B, that's the angle, and the angle across B is lowercase b. So here I'm going to divide this by lowercase b. And that's what the law of sines says. The sine of capital A to lowercase a is equal to the sine of capital B to lowercase b. So let's go ahead and apply this and show you how this works. Here it says find the length of PR, and round to the nearest hundredth if necessary. Now here I've written my skeleton. This is the generic formula, and now I'm going to apply it to this problem right here. We're trying to find the length PR, and PR is this one. I'm going to call it X. So we're trying to solve for X. So notice here that I was given two angles. I'm going to make use of them. Here, I'm going to get angle P, which is 32 degrees, and I'm going to divide it by the length that's across 32 degrees, which is 5.6. So here I'm mimicking sine of A over little a. So here I can say sine of 32 degrees is to 5.6. There we go. Now that's going to equal, I can grab another angle, and I'm going to use 115 degrees since I was given this angle. So this is going to equal sine of 115 to the length X. So I get sine of 115 all over X. We have a proportion with 3 known values and 1 unknown, which means we can solve for this. So here we didn't necessarily have a right triangle, but we were still capable of using algebra in order to attempt to find this missing length. And after this is all said and done, you'll see that we will succeed. We have a proportion, so let's apply the cross multiplication. So X times sine of 32 is going to equal to 5.6 times sine of 115. And let's split this equation in half. On the left hand side, I have X sine of 32, and on the right hand side I have 5.6 sine of 115. The objective is to isolate x. So here, notice that we're multiplying. So in order to isolate x, I'm going to have to do the opposite and divide by that sine of 32. And whatever I do on one side, I have to do it to the other. So the other side is going to get divided by sine of 32 as well. On the left hand side, sine of 32 over sine of 32, that's just 1. So we get x multiplied by 1. And on the right hand side, we get this 5.6 sine of 115 all over sine of 32. And now this is a problem for the calculator to solve for us. So here, x times 1, that's just x. I'm going to calculate the numerator first. I'm getting an approximation of 5.08. And now this is the numerator. Now it's going to get divided by sine of 32. Now keep in mind that you could put this all at once, but you have to know how to input it correctly. So for now, I'm showing you how to do it by parts. And then maybe I can do a screencast on decimals and show you how to do it all at once, or maybe I can find a video using a calculator. But in the meantime, let's go with this. So now I'm going to write 5.08 and divide it by sine of 32. And I am getting an approximation of 9.59, rounding to the nearest hundredth, because that's what the problem suggested, rounding to the nearest hundredth. So we were able to solve a missing length from a triangle that's not 90 degrees. So cool. We've just extended our skill set. So the formula is pretty nice. It's very easy to use. So let's try it on one more problem. So let's take the same triangle here. But this time we're going to solve for length PR. We solved for PR. I think here. Yeah, so let's solve for PQ this time. Again, this time we're going to solve for PQ. So let's solve for this part right there. So let's call this part Y. Here, in order to apply the law of sines, and let me rewrite it really quickly. In order to use it, we need to apply an angle and a length. And you can see here that this length, we don't know the angle. However, technically we can figure it out, because remember that every triangle, whether it's right or not, due to the sum angle theorem, all of the angles have to add to 180. So let's go ahead and figure this out. So we have 180, and if we subtract 32 and then subtract 115, we should get the value of angle R. And this is going to come to 33 degrees. So here we have 33 degrees, and now we can apply the sine of 33 to Y. Now, just for the fun of it, since we already solved for PR, let's include that length, which is 9.59. So let's write 9.59 here. Here we have options, so I'm going to give you both of them. So let's say we want to solve for Y. We're definitely going to have to use this pair. So let's write sine of 33. That's going to be to the length Y. And we're going to set that equal to, and here's where we have a choice. Since we know this side, we can set it equal to the sine of 9.59 to 115, or we can set it equal to the sine of 32 to the length of 5.6. So let me write both of them down, beginning with this one, sine of 32 to 5.6. Sine of 32 to 5.6. This one right there. This is valid, and this is technically all we need in order to solve for Y. However, you can also do this. You could do sine of 33 over Y and set it equal to the sine of 115. So sine of 115 all over 9.59. These two setups should give you the same answer. I'm going to do this one, and for the extra practice, I encourage you to verify that doing this problem gives you the exact same thing. So I'm going to focus on the first one I wrote. So let's set up the proportion here. cross multiplying, I'm going to get 5.6 and multiply sine of 33. This is going to equal y multiplied to sine of 32. And we can split this equation in half. And now here, I want to isolate y. So I got to get rid of this sine of 32. And I'm going to do this by dividing by sine of 32. And whatever I do to one side of the equation, I have to do it on the other side. So here, the left gets divided by sine of 32 as well. So sine of 32 divided by sine of 32, that's just 1. So we get 1 times y, or y times 1, is equal to 5.6 sine of 33 all over sine of 22, or 32, sine of 32. I'm going to calculate the numerator first, so y times 1 is y, and 5.6 sine of 33 approximates, so here let me do the squigglies, they approximate to 3.05. And now we're going to divide that by sine of 32. And once I divide by sine of 32, we're going to get that y is approximately equal to 5.76. And that is the length, 5.76. And we are done. So go ahead and finish the assignment, and I'll see you on the next lesson.